Hi, folks. I'm Ajay Nair, the Senior Product Manager in charge of AWS Lambda, and welcome to MBL302. Along with Olivia Klein, a member of our AWS Solutions Architects team, we're here to talk to you about building scalable serverless mobile and IoT backends with AWS Lambda. For those who aren't familiar with the service, we're going to start with a brief introduction, what Lambda is, what benefits it offers you as developers, what people are doing with it, and how you put it to work. We'll then walk through a step-by-step introduction into building a geosocial application using the suite of services that AWS offers for helping mobile developers such as you. These include Amazon Cognito, Analytics, SNS, DynamoDB, and of course, Lambda at its heart. Finally, we will have EzTen, top 5 actually, Russian App Store member, who will walk through how they rebuild their entire mobile backend powering the application with AWS Lambda at its heart and adopt the serverless approach. So let's get started. A little bit about Lambda. We talk about Lambda as an event-driven compute service. When we say compute service, we mean that it allows you to run code, arbitrary code of your choice, without having to manage any servers. You simply give us your code as a Lambda function, and AWS takes care of the rest. We provision the capacity, route the requests, load balance across the traffic required, configure the environment. There's no additional step that you need to do other than supply the code. Now, the code that you give us only runs when it needs to run in response to what we call events. These events can be changes in data, changes in state of your various infrastructure, an HTTP request from your client, or direct calls to our APIs. All right. Building applications with Lambda offers you 3 key benefits. First, the approach is serverless. And when I say serverless, not that there are unicorns powering it on the back end, it's just that you don't have to think about the servers that are doing the work. There's no capacity to provision, no load balance to set up, no network to configure, no environments to patch, no machines to tinker around to build a highly available, scalable application. The operational tasks that you're saving time on have a direct impact on your productivity. For example, Vidroll, who's built their video ad serving system using Lambda, tell us that what previously used to take them 10 developers now takes them 3. So straight up 3x productivity for the same kind of tasks that they were doing for building the application. Second, Lambda offers event-driven scale. What this means is Lambda automatically spins up the amount of capacity or instances of your code required to serve as many number of events are being called for your code. There's no capacity to provision, there's no over-provisioning or under-provisioning, there are no auto-scaling rules to set up. Lambda automatically figures out what is needed for the incoming traffic and sets up the number of code. Whether you are a small startup on day one, getting 100 requests a day, or someone like Localytics, who's doing billions of events through Kinesis and Lambda, Lambda automatically sets up the amount of scale required for your operations. Third, and in some ways, the one that actually excites a lot of developers is sub-second billing. With Lambda, you only pay when your code is executing. You pay when your code starts running to the time when your code stops running in units of 100 milliseconds, right? So think about it. With Lambda, you're not paying for idle ever. You're only paying when your code is actually executing, which means you can build a very high-scale app, potentially at very low cost. While Lambda changes the way you operate and build your applications, we still want to make certain things exactly the same. Lambda allows you to bring your own code in languages you know and love. Lambda supports Node and Java, and as of this morning, it supports Python. You can write the code, shell out the binaries, have threads working, package native dependencies, write application code the exact same way that you do today, package it as a Lambda function, and deploy it. You have control of how much compute power is available to your Lambda function. Lambda gives you a simple resource model. Simply slide up the memory in units of 64 MB all the way up to 1.5 gigs, and it allocates proportional CPU to you, essentially giving you a bigger and bigger box. You need more compute power and horsepower to run the kind of code you have, you just dial up that single dial. The same function that you set up can be invoked in different ways. You can configure it automatically to run when certain events happen, such as an S3 bucket getting updated, a DynamoDB table getting updated, or a Kinesis stream getting updated. You can invoke the function using an HTTP request by fronting it with API gateway, or you can use the Lambda APIs to write your own client, or the mobile SDKs to write your own client, and just invoke the Lambda function on demand. And finally, while your code can do anything, it's your code after all, what it does within the AWS ecosystem is completely under your control because Lambda works with the identity and access management tools that AWS offers you. Now, Lambda is a way to build applications, so there's a development workflow. Again, the goal here is familiarity. Build applications the same way that you do it, but changes the way how it runs in the cloud. First, you can author Lambda Functions, the tools you care about. We support Eclipse IDE plugins. You can use the Lambda console for authoring the code that you care about if it's in Node and Python. Visual Studio IDE plugins for Node.js, or Vim for the power users you have inside here. Once your code is written, you specify a few simple configurations, the amount of memory you need, the role you wanted to assume for the permissions that you care about, the event sources that you want to trigger this particular function, or the API gateway you want it to be associated with. You take the library dependencies in the code that you have and the configuration and package it as a deployment package and publish it to Lambda. To do this, you can use CI/CD tools that you're familiar with. Lambda has a Jenkins plugin, supports ThoughtWorks, has Grunt plugins. As of this morning, we announced the ability for you to version and deploy your functions, so you can follow a staged deployment approach for pushing your Lambda code outside. Once your code is up and running, Lambda automatically instruments and monitors your code and publishes all the logs into CloudWatch logs. Any statements that you write in your code for logging automatically get published to a corresponding CloudWatch log stream and generate corresponding CloudWatch log metrics such as invocations, durations, and errors. That's great. So what do people do with an event-driven compute system? We see three major patterns. First, people building interactive backends. You have a Lambda function. You invoke it synchronously using the mobile SDK client or using HTTP. You will actually see a great example of this when EzTen is up on stage. The second big pattern we see is having customers use Lambda for data processing. Customers like Thomson Reuters are using S3 plus Lambda for doing large-scale file processing of all the content they get from different publishers. You can use Lambda for log filtering, video transcoding, and all the way to genetic algorithm mashing like some of our customers have been able to do. The point I want to make here, though, is since Lambda allows you to run arbitrary code, the complexity of the tasks that you can do is essentially bounded by essentially the code that you can write. The same model applies to DynamoDB. The ability for you to write triggers for a NoSQL store opens up new avenues. You can now validate individual rows that are being written to DynamoDB. You can add calculated columns as soon as the data is written. You can copy a partition copy of your data into cross regions, all with a single Lambda functions attached to your DynamoDB table. And the third pattern, in some ways the most fun pattern, is Lambda acting as sort of an extensibility story for various AWS services, as well as non-AWS services. For example, Lambda is being used to power Alexa voice skills. You can write a Lambda function that defines what happens when you talk to Alexa, the voice assistant offered by Amazon. You can specify a Lambda function as a custom resource within a CloudFormation deployment that tells what happens or what should happen when a stack is deployed and completed deployment over there. You can also use Lambda as an extension for simple notification service and customize what happens or when an SNS notification comes in. This opens up avenues such as using Lambda for customizing CloudWatch alarms that many of you will be managing in your day-to-day tasks. And the list continues to grow. Now, today, we're going to be focusing on a specific pattern, which is using Lambda for cloud backends for mobile apps. But stepping back a second, what does that mean, right? When we think of a mobile backend in the cloud, we think of things that are not that they're impossible to do on the device, but they're hard to do. Think about things like user administration, storing the identity and credentials associated with the user, properties associated with the user that you want to make available across multiple devices they log in on. Where would you store the content that's being uploaded through a mobile device as part of interacting with your app? What about push notifications? If you want to engage customers as a result of their app activity or as a result of someone else using your app, how do you engage back to them? Analyzing user behavior so that you know what are the next cool set of features you should be building for the things that your customers are doing. And last, and something that probably not everyone thinks of, is where your app logic should be running. App logic in the client is great, but now that adds an additional task for rebuilding it when you're having a cross-platform opportunity, or pushing out new versions of your code requires you to propagate through the App Store. The backend that you build has some certain unique characteristics we have heard a lot from mobile developers. Cost should follow usage. If my app is not getting the millions of users I thought it would on day one, I don't want to be paying for the cost of supporting millions of users. If I get the million users, hey, take my money, right? Minimal undifferentiated heavy lifting, which is my job is to build the app. The app logic is what makes my business different, but I don't want to be in the business of configuring infrastructure. Iterating quickly and reducing my time to market such that I can get the next feature out there and grow my user base. And finally, when that success point comes in, I get the instant scale I need while maintaining a reliable and secure backend that doesn't drop the experience for my customers. AWS offers a suite of services that allow you to build different pieces of this. We have Amazon Cognito that allows you to authenticate your end users and store user data associated with them. Amazon S3 gives you a reliable store for any content that's being pushed in through your app. SNS allows you to engage with these customers through push notifications, and mobile analytics allows you to analyze the behavior of the users within your app and figure out through easy-to-use analytics what the next step should be. And Lambda gives you a way to run the business logic that you need to back your app and a way to glue all these services together without having to set up and manage any servers. Along with DynamoDB that gives you a reliable NoSQL store, the mobile SDKs that give you a front and easy way to integrate within your mobile app independent of platform, and API gateway that opens up the possibility to use your backend across different clients, including web apps. You now have a pretty rich, powerful set of tools to build the backend that you need. So enough theory. Let's get back into what a real app looks like. We're going to walk you through an app that we call Find Like. It creates a profile with interests and gets notified when like-minded users are nearby. At reInvent, we have a lot of like-minded people. Everyone's asking the question, where's the best food? Where should I go for the pub crawl? Is Taylor Swift really going to show up at the Replay conference? These are all important discussions that people like to have, and an app like this can help. How would you go about building this app, right? You as a user come in, I set up a profile, specify what my interests are, maybe upload a picture, straightforward enough. Many of you build apps that do that. I want to be able to track the location of you as a user and tell you where you are so that I can find nearby people. A little bit more complicated, requires some custom logic in the backend, doable. And now comes sort of the secret sauce of your app, which is when locations change, interests change, or even your profile change, figuring out and then notifying you, hey, someone nearby likes the same things that you do, all the while keeping and tracking what the interesting behavior of your end user is within your app. Now, to walk you through the code and the architecture involved in this, I'm going to invite Olivia on stage. Olivia?
Thank you, Ajay. Good afternoon, everyone. So basically, when we develop an application, it's good to think about the functionalities. But another thing that I like to do when I develop something is to say, how about we break this down into different kind of layers and approach it like an onion that we peel. If you think about this app where we say, OK, I can collect interests from a certain user. He creates a profile. He tells us what he likes. And then we track his location. And we match those users together that are in the same vicinity and have similar interests. We could see that by laying it in 3 layers. The first one would be what I like to refer to as the app-centric layer, the U layer, what you do within that application on your phone. This would be creating your profile, taking a selfie of yourself, uploading that into your profile, and also tracking the usage of what you're doing. The next thing now is, as you use that app, you're going to walk around with it, you're going to add new interests into it. This is the activity-centric layer that we're going to talk about, which is the second one. So track the location and collect the user interests. Lastly, as we now have multiple users using that app, and we're tracking locations of many different users in different vicinities, including the interests that they have, we want to now match users that are together with similar like-minded interests in a certain radius, and then alert them accordingly. If we want to build this with AWS, on the right side, you see the service icons of what we would use. So for the first layer, we're going to leverage on Amazon Cognito, Amazon Mobile Analytics, and Amazon S3. For the second layer, we're going to leverage Amazon's API gateway, AWS Lambda, and also DynamoDB to store the interests. And lastly, when we match and alert users, the matching logic, we're going to put it into a Lambda function. And to notify the users, we're going to use Amazon SNS Mobile push. All right, so let's go to this one by one. So first layer, creating a profile, uploading content, and tracking usage. Now, when we want to use AWS services, we generally want to not write the RESTful API calls ourselves. For that reason, we have SDKs for various programming languages. Now, this includes SDKs that are specifically targeted for mobile, specifically for iOS and Android, and we also got some other frameworks like Unity, for example, where we got SDKs for it. Why would I use that mobile SDK? Well, it doesn't only allow me to talk to the core building block services, which the other SDKs would do, but it also adds another layer, which is mobile-optimized connectors to those services. As you know, with a mobile device, you might not always have connectivity. It might be choppy. You might not always be connected, etc. If you write your own API calls yourself, you kind of need to handle that. If you do a file upload, you need to make sure it resumes. If you want to write something into a Kinesis stream, you want to make sure if it's available or not, or buffer it if it isn't, and then have kind of a exponential backoff algorithm that retries if it wouldn't work. Those optimized connectors do that for you. So if you use the mobile SDK and you leverage, for example, the S3 transfer utility, then we take all that heavy lift of retrying and resuming things for you, so that you can focus purely on building your application, yet leverage our services straight from the device. Now, if we do an API call against AWS, this one always needs to be authenticated and secured. For this, we have a principle called identity and access management, which allows us to get access keys and secret access keys to make those API calls. Now, obviously, you never want to hard code those credentials within your application. So what you can do is you leverage temporary security tokens, which you can obtain from the AWS Security Token Service, STS, which basically talks to IAM, looks at the IAM roles that you have configured, gives that roles the permission, creates a temporary token, sends that back to your device so that you can then sign the API request to another AWS service that you have, sign the payload, and connect to that AWS service, such as, for example, an S3 bucket. Now, you see, this is a certain process that we would need to follow. So we wanted to make this easier for you. For that reason, we launched a service called Amazon Cognito. What is Amazon Cognito? Well, it allows you to authenticate your users anonymously or through third-party providers, such as, for example, Facebook, Twitter, Google, Amazon, any OpenID provider, or even your own authentication or login mechanism. Cognito will then automatically issue a temporary credential and also rotate this temporary credential so that you align with some of the best practices around IAM security with AWS. It also allows you to share that identity across multiple devices. So if you have a phone, if you have a tablet, if I log in, if I use the app on both devices and I log in through my Facebook account, for example, Cognito will know that this is the same user on those two different devices. If I want to implement this, I just want to show you a little code snippet here. This is for an iOS device, an Apple device. How would that look like? Well, basically, you initialize the AWS Cognito credentials provider object, so you allocate that one, and you just give us a few information, such as what is your AWS account ID, what is the the region you're doing this in, and what is the Cognito identity pool that you previously created that you want to use. And then you also tell us what is the authenticated and unauthenticated IAM role that you want to give this user if he connects to, so that we can give him the permission through that role. The next thing you can do now is to say, every subsequent calls to AWS services, I want to leverage Cognito as that identity provider so that those temporary tokens that we created, they are used to make the other subsequent AWS API calls. To do that, we can change the AWS service configuration, which is the third line of code that you see here, and we just say this new Cognito credentials provider becomes our default service configuration. So every subsequent AWS call will now use the temporary credentials issued by Cognito to make subsequent calls. Cognito has another interesting functionality, which is to synchronize locally stored key value pairs from the devices across your devices. So going back to the app that we're building, we want to create a profile, and that profile contains certain information, such as my username, for example, or my name in general. And then another thing, since this app is find a like who is in a certain area, right? So we want to define a certain interest radius in which we want to be matched, right? And by the way, this is kilometers. You see I'm a European. I adapt the metric system. But somebody can probably convert that to miles for me. So how would I use this? Well, basically with Cognito Sync, I write key value pairs locally on the device. Cognito will automatically sync that with the Cognito service in AWS. And if you have another device, synchronize those key value pairs to those other devices. How would I leverage it? Well, basically, you see the piece of code right here. You initialize the Cognito object. You then open or create a data set. This will create a local preference file on the device, or if it already exists, it will just open that local preference file, which is basically a small SQLite preference file database. You then set the key values that you want to have. Here, I'm just going to give an example of setting a name and the interest radius of what I want to be matched. And then I can tell Cognito to synchronize this. And Cognito will now automatically maintain this profile and synchronize it not only with my cloud environment, but also with all the other devices where I potentially have this application installed. Now, I mentioned we also want to take pictures, and we want to upload this. Where's a good place to store user-generated content? In Amazon S3. For those of you who don't know what Amazon S3 is, it's our simple storage service, that's S3, which allows you to put any kind of objects into so-called S3 buckets. They have virtually unlimited storage space, so you don't need to tell us how much storage you want to capacitate, and we only charge you for exactly what you use. So perfect place to store user-generated content. Now, if we talk to S3, we're going to leverage the mobile SDK's functionalities by using the S3 transfer utility. The S3 transfer utility makes our life a little bit easier because we just tell him what is the data or the file that we want to upload, and it handles the rest, meaning that if a file upload will get interrupted, it will try to resume it. If you put your application in the background, it will leverage the background CPU time that it has to actually upload that file. So the different varieties between Android and iOS devices, how much time you have, the S3 transfer utility takes care of that. And it also allows you to upload binary data straight. So sometimes you might take a picture and then you write it locally to a file on the device, then upload it. With the transfer utility, you can straight away send that binary data into an S3 bucket. So we take a picture, we upload it to the S3 transfer utility. How would that look like in terms of code? It would look like this. We initialize an AWS transfer utility object. We then give it the data that we want to upload. So here I took binary data, thus NS data, which contains the binary data that I want to upload. I just tell it which S3 bucket I want to put this in, how I want to name it, which is the key prefix, as we refer to it, and just give it some additional information, such as content type, which is optional. This is all I need to do. Now the data automatically moves into my S3 bucket. The S3 transfer utility is aware if you get disconnected and resumes the file uploads. Now, lastly, if we create a mobile application, we also want to understand our users a little bit better. And for that reason, we want to track them from day one. So for this, we're going to leverage Amazon Mobile Analytics, which allows us to collect, visualize, and understand the app usage of your application that you're building. Things like, what are my daily active users? What is the stickiness factor of an individual user? How many open sessions does he have? As most AWS services, this is designed to scale for potentially billions of events, fully scalable in the sense that you don't need to worry about that. And one important thing, you retain full control and ownership of all the data that is logged through mobile analytics. So you own that data, and you can move it around, for example, in your S3 bucket or into your data warehouse. How would I use this? The mobile SDK, again, makes our life fairly easy. It's one line of code to enable it. You just initialize the mobile analytics object. You tell us what is the application ID that you created in the mobile analytics service, and it will now automatically lock in the background the activity of the app. In addition to that, you can also set custom events or even monetization events. So if you have in-app purchases or you have a specific activity that you want to lock, you can also lock that easily by one line of code. This is the way it would look like on a dashboard. This is the default dashboard that you would get with some information around stickiness factor, retentions, etc. And if you log custom events, you would also be able to explore those custom events and drill in. In addition to that, if this is not enough, since this is potentially just a basic overview, you can export that data into your data warehouse, into your S3 bucket, and then potentially leverage other services like QuickSight to visualize that more complex. Now, we achieved the basic parts of the application now, right? We authenticated the user, we allow him to create the profile, set his name, tell us what is the radius that I want to look for other matches, and I allow him to upload pictures. Well, let's get to the juicier part, which is we need to track the location of the user, and we also want to understand what his user interests are and store those somewhere. So how would we go ahead with something like this? Well, generally you have a mobile application, and then we have a certain backend logic, and we need to have a database where we store information such as the location or the different interests that I have. Now, in older days, you probably think that means lots of EC2 and load balancer, and then a certain database that I need to scale to create that API backend. Now, with Lambda, we have new capabilities now. So the way we can achieve this is to say, let's create a microservice together with Lambda and the Amazon API gateway, and let's store information of the user in a managed database, such as Amazon DynamoDB, which is our fully managed NoSQL database. So the way this would look like now is that you create a Lambda function for every individual microservice that you want to have, such as, for example, I want to report the location of a user. As he walks around, I have his GPS coordinates, and I want to send this back. Where I'm going to send it to? Well, to Amazon API Gateway, which then calls the Lambda function. Here you see an example of how that could look like. So it could be a RESTful call to /location. This would call the report location Lambda function, which in effect stores that information then in the location table of DynamoDB. And we just log user and the different locations in which they are. Similar, if we want to have interests, right? If somebody likes an interest or dislikes an interest, the call will be made against Amazon's API gateway, calls the Lambda function, stores that information into DynamoDB table. Now, this allows you to now say all the functionalities that I'm creating for my app becomes such a microservice of a Lambda function, fronted by the API gateway, backed by the Amazon DynamoDB database to store that information. Now, if we talk about geolocation, you might say, well, how do I store GIS data in DynamoDB? Well, there's a concept called Geo Hash, which is basically a geocode system to code latitude and longitude in one hash that can potentially be numerical. I'm not going to go into too much detail, but just roughly outlining it. How does it work? Well, it's basically saying, let's imagine planet Earth in terms of cells that we have. We're divided into 6 cells. We could name those A, B, C, D, E, F, for example. And then we take those cells and we divide each of those cells into subcells, and those cells into subcells, and so on. And that allows us to basically drill down to a specific location. That's what a GeoHash is about. So if you would look at a scenario here, where we have a square, if you see the red dot here, if that's the location I want to look around, then that would be A224, for example. This can be fully numerical, which allows us to put it into DynamoDB. So it could be a numerical number like the one that you see here on the left side, and that allows us to put it into DynamoDB and use the normal indexation principles of DynamoDB to search in between certain strings or numbers here to define the location. Now you're going to say, that's great, so now I know how to store it, but how am I going to use it? I don't want to write the code for, to do geohashing properly. Well, we actually provide you with a library for Amazon DynamoDB to actually create and query those geospatial geohash data. So the good news is this library is written in Java, and as such, we can put it into a Lambda function, right? Because Lambda supports Java, Node.js, and also Python today. How would that look like in terms of if we use that library? Well, we can define a geopoint. This is the latitude, longitude that we would get from our device itself. Here I put in the latitude, longitude of Seattle Space Needle, actually. And then we can do, for example, requests against it. So if we want to say, give me everything that is 250 meters away from the dot that I just pointed, which is Seattle Space Needle, it's as easy as saying, create a radius request, give me the distance that I have to that radius, and query the results, which will now go to DynamoDB sort it accordingly, and find that location. So that's great, because that allows us now to create matching algorithms. By the way, if you want to know where to get that, we got a GitHub subpage called AWS Labs. A lot of the code that we produce, you can find it there. This one is under DynamoDB-Geo. Now, I mentioned API Gateway. For those of you who don't know what API Gateway is, it's a fully managed RESTful API Gateway service that we channel or power through our global content delivery network that has 53 edge locations all across the world. Given that, we also provide you with a certain distributed denial of service, DDoS protection around it, and we also give you the capability to throttle individual users, which is important. If you have some potential abusive user, you can actually start throttling him through our gateway service. We also give you different stages, so you can say, I have a production, a test, or a development gateway, and I plug that around or change around the API calls that I have. The API calls themselves go against an origin, which would be, in this scenario, our microservice, a Lambda function, but this could also go against a virtual service, such as an EC2, or even your on-premise server. Now you're going to tell me, well, but the mobile SDK actually has a Lambda invocation method. Why don't I just call the Lambda function straight from my device? Nothing wrong with doing that, but plugging in the API gateway gives you a bunch of different benefits. The first one is it's easy for you to interchange the Lambda function that you're calling without actually changing the code that your mobile application has. As you know, when you change code, you need to deploy it back to the App Store, the Google Play Store, et cetera, and there's a certain period of time that it takes to actually get revalidated. So having API gateway in between allows you to change things like a Lambda function fairly easily in terms of what we invoke without changing that mobile code. In addition to that, we get the protection of network layer attacks all the way from layer 7 down to layer 3 attacks, such as synflots, for example. And most importantly, we also gain a caching layer. If you think about this application that we're building, we're tracking people's interests, right? So we could have one API call that just lists the interests of a certain user. This is something that doesn't necessarily change all the time. So you could say that list command, I could cache it for, half an hour, for example. With API Gateway, we can cache it within the API Gateway service so that we don't always need to call the Lambda function and make the DynamoDB request, but it comes straight from that cache. So those are some benefits that you get when plugging API Gateway in between. So we now created also the possibility of tracking the location of the user using the principle of leveraging a microservice, API Gateway plus Lambda, and a backend storage such as DynamoDB. Now, how about creating now the functionality that actually makes out the app? I want to match users together. How would I go ahead of that? Well, Lambda can help here. So click. There we go. If we think about what we achieved, we basically have different information coming into different services from different mobile devices from all our user base. We track the location into DynamoDB using the Geo Hash principle. We have pictures that get uploaded into S3 buckets. We have profiles that get set and changed, and we potentially change interests, radius that we have created. I want to match 10 kilometers, 50 kilometers away from me. Those changes which go against Cognito, and as such, Cognito sync. So we have all this information and these events that are coming in. Now, what can we do with that? Well, we can leverage Lambda to interact on these events as they're coming in by using DynamoDB streams, S3 event notifications, and Cognito sync triggers. Now, that's great because all those movable components that we have actually allow us to define if we have a match. So let's think about it. The mobile device basically makes a RESTful API call to our Amazon API Gateway, which reports the location back into a DynamoDB geohash table using a Lambda function. Now, this in effect will trigger the DynamoDB stream. A DynamoDB stream, we can connect it to another Lambda function. And that Lambda function now sees what are the new information that are coming in, which allows me to say, well, there's one person that is moving, so let's see what his interests are. Let's look at his proximity second, and then we can find other users within his vicinity that can potentially be a match, and then say, oh, we got a match. Now, what if I change my interest? Same thing. An interest, it's a microservice, right? So Amazon API Gateway call against the Lambda function, which could be a like interest function. which in effect updates my DynamoDB interest table, creates a DynamoDB stream, triggers our find match functionality, and we again see, oh, he changed his interest. Is now there's another user that potentially matches him? And if so, we found a match. Now, what if we found a match? This is the code, how it would look like on handling a DynamoDB stream. So the records that are coming in from the DynamoDB table, we go through all of them, and then we have our find proximity match algorithm. I didn't outline that one here, but you would basically just look at the position and find the individual users. What if we found a match? What are we going to do next? We need to alert the user, right? For that reason, we're going to tap onto Amazon's SNS Mobile Push Notification Service, which is a cross-platform mobile push notification service so that you can push to iOS devices, Android devices in China through Baidu, Amazon, Fire devices, or even Windows devices. Again, it's fully managed and scalable, so scales to potentially millions of devices, and it also allows us to create so-called topics, like on a specific geo, on a specific interest, and subscribe our users to those topics, and then push out notifications to a topic, which automatically fans it out to all the users subscribed to that topic. So that's great. So we can tap onto SNS to basically notify the user when we found a match. Remember, we have a few movable components, the interests and the geolocation, the position of the users, which continuously change. And whenever they change, a DynamoDB stream triggers my find match Lambda function, which now makes the decision of, have I found a match or have I not found a match? If I found a match, then I want to notify the user. How do I do that? Well, I'll make an AWS SDK call against Amazon SNS to push out that notification. Because the Lambda function can obviously also leverage the SDKs of AWS to call other Amazon Web Services, such as SNS, for example. Now you're going to say, OK, this is great, but what if I change my profile? What if I change that I want to match people that are further away from me or closer by from me? Then this might not work, right? Because I don't get an update on the DynamoDB table, and as such, I might miss out on a few matches that I would otherwise have. Well, remember, Cognito Sync is good to synchronize data across your devices, but also to synchronize state that you have locally set on your device to Amazon. And that, in effect, actually triggers something called a Cognito Sync trigger, which we can then connect to a Lambda function. So we can say, whenever there's a Cognito Sync event, trigger a Lambda function. And that Lambda function could then look at what has changed. So it would go to, OK, give me the data set of that specific user that just changed something. Hey, he changed his interest radius because we have a replace operation on that value. If that's the case, we need to process again if we found a match on that person. Now, we can put the match algorithm into this Lambda function, but how about we reuse what we already have? So we can leverage the find match function that we already built earlier. So what we're going to do in this Lambda function is just to say, if interest radio has changed, revalue it. How do I do that? Well, call the find match Lambda function. So we call a Lambda function within a Lambda function. We basically chain the Lambda functions together, which is what I'm doing here. I'm invoking the Lambda function asynchronously, the find match function from this Lambda function. Why asynchronously? I want this function to terminate and have the other find match function do the rest. I don't want to wait for the find match function to come back. If you want to do that, you can change the invocation type. So both asynchronous and synchronous invocations are possible. So basically, we now went through all the layers. We have achieved all the functionalities that we actually require. And if we were to draw that out into a final architecture diagram, it would look like this. So we have our mobile application. We tap onto the mobile SDKs to talk to Amazon's web services. We store our profile in Amazon Cognito, potentially authenticate users against other third-party providers, such as Facebook. We track usage through the mobile analytics service. Whenever we need to report location or update interests, we tap onto the principle of a microservice, which is a combination of Amazon's API gateway, a Lambda function, and a backend store, which could be a DynamoDB table. Those are the movable components that call DynamoDB streams or S3 event triggers that can call other Lambda function. And if we then found a match, we're going to notify the end user using Amazon SNS. And all this basically achieved fully event-driven without running any servers and only running our matching algorithm that very moment when something in our system is moving around. Now with that, I want to pass this on to an actual real-life use case. So I'm going to call up on stage Kirill and Vasily from EzTen. Thank you. There you go. That's for me.
Thank you, Olivia. We're co-founders of a startup company from Moscow, Russia called EzTen. I'm Cyril, Kirill is backend team lead, and we develop a mobile app that helps people learn foreign languages by studying 10 words a day. We got over 1.2 million downloads, and we've been featured by Apple in over 85 countries. Currently, our main markets are Russia and Brazil, but we're available globally, so you can download the app and play with it right now. So what the app does is it allows you to pick your language level and interests. Then it presents you a feed of foreign words based on which we pick for you based on your learning habits. Each new day you pick 10 words from that feed, and after that you challenge yourself with various tests to repeat and ensure you've learned the words. Our goal is to make learning languages more entertaining, productive, and time efficient. So we're going to share with you today our experience moving to a completely serverless architecture style and outline the benefits we see in this approach.
In our app, Backend handles functions like user authorization, content update, leaderboard, social features, and so on. While developing and maintaining our application, we started facing different problems as the system grown. So let's take a brief look on our previous approach. It was a large monolithic application which was running on multiple dedicated servers, and that cost us a sensible amount of money every month. It was extremely difficult to keep backend architecture loosely coupled, so we ended up having lots of unnecessary dependencies, and that caused a drastic increase in development time. We paid our dedicated DevOps team while still having to wait a while whenever we wanted to adjust process configuration or conduct a load testing or so on. And also, we spent a lot of time trying to build even quite simple prototypes because we had to deal with application security, scalability, and resilience. We've been also very limited in technologies we can use because we realized it will take a while for us to implement them.
So the natural solution for us was to go for a microservice-based architecture. And the question for us was, how do we build a microservice backend on AWS, solving all the problems stated above? And we obviously wanted to avoid all server administration costs and work with managed services only. And after iterative prototyping and research, we came up with a serverless framework for building microservices based on Lambda, DynamoDB, and Kinesis. Why we call this a framework is because the certain way of arranging those services was general enough for us to fit all of the business logic within it. Even the complex cases like real-time word selection and leaderboard and so on. We no longer work with any kind of dedicated system administrators because developers are now able to do all the necessary setup themselves. This reduced our costs greatly, increased the development velocity, and the variety of technologies we use.
Each microservice can be deployed independently and without downtime within this framework, which is a huge improvement over our previous approach. Also, every single engineer can build a working prototype solution in a matter of just few hours. No database configuration, no sharding, replication, scaling, no worries about security and authorization. Hardware is fully abstracted. And there is another huge benefit in this approach, which is AWS Mobile SDK. It allows you to use all the services as fast and easy as possible without thinking about integration issues like weak internet connection, retry policies, caching, and so on.
So this is the basic scheme of our microservice framework. And the core of a microservice is what allows for all the basic features that we need. It's DynamoDB for data storage. It's exposing interfaces to client applications through Lambda endpoints and Kinesis streams. And data processing using Lambda Kinesis consumers and internal Lambda functions which are triggered from the endpoints. Also, each microservice has a DynamoDB log for event sourcing purposes, and additional services are used on demand based on the needs of specific microservice. So we'll now review a sophisticated scenario of how the microservice call works and makes use of additional services.
In our app, user can reject or accept awards which were given to him, and we use this data to provide real-time recommendations. So what do we need to accomplish that? Well, first, we need a way to react on user behavior events. Then in response, we should do some computations and a database lookup for pre-computed recommendations. Then we should return updated data back to client, and we should also keep track of user activity and session for further analysis. Let's see, the app is opens. It calls Lambda function, which creates a new session and logs it into DynamoDB table. It also generates an SQS queue and returns it back to client, so we can establish a live connection. While user is going through the words, we track his activity via Kinesis events. We then process them within Lambda function, which updates user record and also executes the business logic, which tells us whether updates are ready or not. As soon as we get new content, we push it back to SQS. Client app listens to it and immediately updates the UI. As a result, user can see an updated word in his feed. So, as you can see, Lambda does an exceptional job in both handling common and very specific use cases. The latency between sending events from Kinesis, from client to Kinesis, then processing them within Lambda, then pushing them back to SQS, is so small that we can easily use this approach for real-time processing. At the same time, we use Lambda for common cases like validating purchases, user data synchronization, and so on.
So this solution now works on the cross-testing stage and going live within a month. But some of our products like Chrome extension and Telegram bot are already running on this framework. And based on our usage metrics, we expect the reduction in our database costs by over 80% and reduction of our computation costs by at least 65%, which is absolutely awesome. We're actually very happy with the outcome because when we started experimenting with this approach, we were absolutely uncertain about whether it will work at all or not. It was quite heavy a change in terms of a mindset because we were now actually working with AWS as a software development platform, just as Android or iOS developers would work with Apple or Google. What that means is that we were now imposing a number of limitations on ourselves, but in the end, we were gaining what we were really looking for, that is development velocity and the ability to focus on product delivery, focus on what we are good at. To end our speech, I would like to go briefly through our wish list and plans. So, by the time we started experimenting with Lambda, API Gateway was not available. And now we're suddenly looking forward to replace all direct Lambda invocations with API Gateway layer to increase flexibility and security. We're going to use DynamoDB streams for replication purposes, and we also want to track several business metrics in real time using them. Some tasks could not be done with simple function invocation. You need to orchestrate them in a specific sequence or schedule them. The simplest case would be tracking renewable subscriptions from Apple or Google. And we're planning to use SWF for that. And actually, our wish list is empty now because it consisted of new languages for Lambda, with Python being on top of the list, and some system for managing for version control and stage management for Lambda, which was released today morning. So
Great.
Thank you very much, EJ.
Great. Thank you, guys. So there you have it. Hello. Hello. All right. So to bring it back, we started with talking about wish list of sorts, saying what does it take to build a backend, making it easier for you. We walked through 2 examples, pretty detailed architectures of how you could achieve user administration, content storage, push notifications, analyzing user behavior, with custom app logic gluing it all together using AWS Lambda in 2 very sophisticated applications, a learning app that has millions of downloads, as well as something that looks like a geosocial apps. That's a pretty common pattern that you see nowadays, with probably about 100, 200 lines of client-side code. The most important part is this architectural approach gives you the following advantages which appeal to you as mobile developers. Cost following usage, all the services we talked about are built based on a per use basis, including Lambda. You're not doing anything other than writing the client-side code and any app-side logic that you care about. Everything else is managed and configured for you. And as EzTen attested, it's reduced the development time from days to hours for getting something into the market without compromising on the scale, reliability, or security that they care about. And what you saw today was only a small sample of what AWS can offer for you as a developer. Now that I've checked the box, we talked about just the development aspect of building this application. AWS offers AWS Device Form, such that you can go and test your Android and iOS apps using a fleet of devices that AWS owns and manages. Simply upload your app, specify the test you want to run, it'll do the rest. The data that you pushed into mobile analytics, as Olivia mentioned, can be piped through Redshift and into Amazon QuickSight, as announced yesterday, to build very custom deep analytics for the kind of resources that you care about. The notifications that you were pushing, instead of just using the default ones, you can use Lambda to customize what you want to do, such as personalizing based on the interest or location or other information that you have about the user, such as their social data. And straight up and manipulating the content you get, watermarking the images, resizing it such that different device and form factors work for it, populating it back to DynamoDB to maintain an index and count of the users that you have. The possibilities that you can do for extending your app are limitless. The most common phrase I've heard from customers is that Lambda makes me faster, right? It's that much easier for you to now write a Lambda function, push it out to prod, and have an instantly scalable code sample out there without having to set up any of the scaffolding. And the same applies to you with the suite of mobile services that are available with AWS. So here's 3 next steps I'll challenge you to do. Download the AWS Mobile SDK and create your first AWS backed app. With the code samples you saw here, you should be up and running in no time. With the new mobile hub capability announced today, I believe the count now is 20 minutes to write your first app and download it. Second, go to the Lambda console and use one of the blueprints available to create your first Lambda function. This morning in the keynote, we had about, I would say, a few hundred people who created their first Python Lambda function before Werner finished talking. It takes about 90 seconds for you to create your first one and have it go up and running. And don't worry about the cost. The first 1 million requests are free on us. So unless you guys are running a load test right now, you won't have any cost showing up. And finally, we're constantly adding new features to all the services we talked about today. And you can follow them using the AWS Mobile and Lambda blog on the compute section of AWS. With that, I'm going to close, and we'll hang out here for questions. Thank you.